Introduction: Sustainable Architecture and Climate Change. Sustainable architecture focuses on designing and constructing buildings in ways that reduce environmental impact and promote energy efficiency. As climate change becomes an increasingly urgent issue, sustainable architecture plays a critical role in mitigating its effects and adapting to its challenges. Energy efficiency in building design. One of the primary ways sustainable architecture addresses climate change is through energy efficiency. Modern sustainable buildings are designed to minimize energy consumption by incorporating high-performance insulation, energy-efficient windows, and advanced HVAC systems. These features reduce the need for heating and cooling, thereby lowering greenhouse gas emissions associated with energy use. Use of renewable energy sources. Sustainable architecture often integrates renewable energy sources to further reduce reliance on fossil fuels. Solar panels, wind turbines, and geothermal systems are common features in green buildings. By harnessing natural energy, these buildings generate clean power and decrease their carbon footprint, contributing to a reduction in overall greenhouse gas emissions. Sustainable materials and resource efficiency. The choice of building materials is another crucial aspect of sustainable architecture. Green buildings prioritize materials that are renewable, recyclable, or have low environmental impact. For example, materials such as bamboo, reclaimed wood, and recycled steel reduce the demand for new resources and minimize waste. Additionally, sustainable architecture emphasizes efficient use of resources during construction and throughout the building's life cycle. Water conservation and management. Water conservation is integral to sustainable architecture. Green buildings incorporate systems like rainwater harvesting, greywater recycling, and low-flow fixtures to reduce water consumption. Effective water management not only conserves a precious resource but also minimizes the impact on local water supplies and reduces the energy needed for water treatment and distribution. Climate-responsive design. Sustainable architecture often involves climate-responsive design, which adapts buildings to their local climate conditions. This includes strategies such as passive solar design, which maximizes natural heating and cooling, and the use of shading devices to reduce heat gain. By aligning building design with environmental conditions, architects can enhance comfort and efficiency while reducing energy consumption. Green roofs and urban green spaces. Green roofs and urban green spaces are emerging trends in sustainable architecture. Green roofs provide insulation, reduce heat island effects, and manage stormwater runoff. Urban green spaces, such as parks and community gardens, contribute to improved air quality, reduce urban heat, and provide ecological benefits. Both strategies help cities adapt to climate change and improve urban resilience. Building certifications and standards. Various certification systems and standards, such as LEED, Leadership in Energy and Environmental Design, and BREEAM, Building Research Establishment Environmental Assessment Method, guide sustainable architecture practices. These certifications provide benchmarks for energy performance, resource efficiency, and overall environmental impact. Buildings that achieve these certifications demonstrate a commitment to sustainability and contribute to broader climate goals. Resilience and adaptation strategies. Sustainable architecture also emphasizes resilience and adaptation strategies to address the impacts of climate change. This includes designing buildings that can withstand extreme weather events, such as flooding, storms, and heat waves. Features like elevated structures, storm-resistant materials, and flood barriers enhance a building's ability to adapt to changing climate conditions and protect occupants. Community and environmental impact. Sustainable architecture extends beyond individual buildings to consider community and environmental impacts. Designing buildings that promote sustainable transportation options, such as bike racks and proximity to public transit, supports broader climate goals. Additionally, sustainable architecture encourages the creation of healthy and vibrant communities by improving air quality, enhancing green spaces, and fostering social connections. Conclusion. The role of sustainable architecture in climate action. Sustainable architecture plays a vital role in addressing climate change by promoting energy efficiency, renewable energy use, and resource conservation. Through innovative design and strategic planning, sustainable buildings reduce their environmental impact and contribute to broader climate goals. As the effects of climate change become more pronounced, the principles and practices of sustainable architecture will be essential in creating resilient and adaptive built environments.